Thank you. All right, so my name is Frans Rosen. I work as a security advisor at Detectify. Everything is like 69 and squeezed, but it will work anyway. I work as a security advisor at Detectify, and we do automation for monitoring websites, basically. So we're looking for vulnerabilities all over the place. And I also do a lot of bug bounties. So I spend a lot of time with HackerOne and BugCrowd and Synac, and I also do a bunch of research there. So I try to find vulnerabilities on these companies and then implement them into our product, and also try to move further all the time. So I'm trying to share everything I'm doing just to keep me up to speed also. So it's a challenge for me by exposing everything I do, which is cool. So I do a lot of blogging at our labs blog. I will mention some of the blog posts, but you should take a look. It's quite fun. I also love this image because I was up in northern Sweden and it was like 35 minus Celsius. And I took the image and I was like, oh, that's fun. I used it as a profile pic, and I met some people outside of Sweden and they're like, yeah, you're dressed as a ninja. Of course. But it's really, so they started to call the Swedish ninja. So I like that. So I'm gonna stick to it. So I'm gonna talk about DNS hijacking, and I'm gonna talk about the background of this because we've been doing research since October 2014 regarding this. And a lot of stuff has happened. So I will go through exactly what happened since then and where we're at right now. I also talk about some tools and techniques people are using today. And I'm going to tell you why those tools doesn't really cover everything, and also what to do with those tools to actually make it work better. Also, mutations of this specific thing, which means that we started with one point of the whole core concept, but then I'm going to talk about how that mutated into totally different areas that still has a lot of potential into doing research. And also some form of mitigations that you can do, and about how to monitor for this. So, subdomain takeover, October 2014. Basically, the concept was like this. Let's take Heroku. Heroku was vulnerable then, still vulnerable today. The basic concept is you as a company is starting a campaign, for example, and you want to host that campaign on a subdomain. And also, Heroku is nice. You can easily just run a dyno on Heroku, and you run your campaign. Everything works really well. You point your subdomain to that Heroku instance. Everything is awesome. Everything works great. But Heroku costs money if you want to get the best out of Heroku. So when the campaign is over, you shut down that Heroku instance. But DNS records are free. It doesn't cost anything to have DNS records. So they shut down the website. Nobody cares about campaign.site.com pointing to Heroku, which basically means that anybody can go in and say, oh, this domain is not used at Heroku. I will register myself on Heroku and say this domain is mine, and I will host whatever you want on it. That's the core concept. And when we posted this 3 years ago, there were 17 providers, the biggest 17 providers that we found back in those days that was vulnerable to this. And we showed a bunch of examples of what you can find, how you can fingerprint those services on subdomains. So you know that, okay, I can probably most likely take over these domains. So this is just, for example, is GitHub, Heroku, S3, and Desk. And when we did this, there was also another guy called Stefano that posted a blog the 12th of October about actually taking over subdomains of a Facebook acquired company. And he spoke a little bit about Heroku doesn't do any validations, so you're able to do this. 9 days later, when we saw that, we posted all our research. And the research was this is all over the place. This is happening all over. And when we started talking with these companies, the services, not the actual vulnerable clients, but when we started talking with the services and you can't do this. Why are you not validating that me as an arbitrary person just comes in and say that this is my domain? And they're like, yeah, we know, we're aware, we know. It's but they don't use it. They don't use us anymore, right? So they're really not our customers. That was one argument. Another argument is yeah, we know it's a security issue, but if you read our documentation, everything says like clearly that you should not do this. You should remove your DNS records when this happens. However, when we started talking with the customers of these services, they threw money at us. They were like, holy shit, why did we not know about this? So all these companies just like poured money just because they were like, we have no idea we were like vulnerable by just forgetting about these DNS records. And we saw a bunch of reports. As soon as we published this, we saw a bunch of reports that actually abused this in a chain of vulnerabilities. One example is a guy called Arne Swinen. And what he did was actually he found a subdomain takeover on Ubiquiti, which is like this Wi-Fi hardware company. And they had their internal SSO allowing any subdomain of their site to actually get the tokens using SSO. Which basically made it possible for him to take over the login for the administrators of this domain also. We've also seen a bunch of reports after this. So people are just like hammering all the companies, finding all these issues, which is hilarious. The problem with it is though that the first report I published back in the days on S3 on Twitter has been copied all the time. So in that copy, it actually says, we have written an advisory over at Detectify. So people are like, oh, hey, Frans, this dude says he's working for Detectify. Is that really true? Because people are just copying the exact same text that I did back in the days, which is quite funny. We've also seen instances just like sneaking up on different places. So you know about certificate transparency, right? So as soon as you're issuing a certificate and somebody's using it in a browser, or if you're using a SSL provider that actually connected to certificate transparency, I think most of them are, those certificates needs to be communicated. So you're able to actually search for what certificates that has been published. And if you look at uber.com today, you will see that one friend of mine called Szymon Gruszewski has actually one issued SSL certificate on one of the domains. This is also like an artifact of basically being able to either control the email or control the website. Another thing was a guy called Jonathan Claudius at Mozilla. He went out in February this year, actually, and talked about subdomain takeover and said, like, this is probably the new form of XSS. Like, we're not seeing this go away anytime soon. And that's also a verification that this is actually a problem that people starting to realize is actually a problem. Hopefully we'll see the service providers actually doing something about it. We've not seen it yet at all. Also, some things happened in even domains that wasn't really claimable. One example was a blog post we did last year, actually. And the case was basically that trailing dot domains, basically a domain with a trailing dot. If you visited that one, a bunch of services said, yeah, but we don't have anything on this trailing dot domain. We have something on the regular domain, but not if you add this trailing dot. And trailing dot is like in the specification of how DNS actually works. So the problem isn't actually in the implementation of how that trailing dot actually works, but as the cloud provider is doing it wrong. And in this case, it was AWS that basically if you add the trailing dot, it said nothing is here. And the problem with AWS and CloudFront in general is that a bunch of big companies are using those. And also CloudFront enables you to upload your own certificates. And there's one sort of certificate that is like really bad to make sure, like to let anybody else have, and that's an EVSSL. And EVSSL is basically like the biggest sort of verification you can do on like, is this domain actually owned by a company? And because that verification actually exists, a bunch of browsers are just like, yeah, we're not even gonna show the domain. We're gonna show the company owning the domain. So by using this trailing dot, we were able to actually host stuff on car.io, which is a PayPal domain, and route it to our own site. So this is actually, it just says paypal.com, but it actually shows you example.com. And the cool thing was, the addition to this was that if you're emailing someone with Yahoo email, and you end the sentence with, yeah, you should go to paypal.com, and end that sentence with a dot, the link to that PayPal would be with a dot. And since this was CloudFront, CloudFront has something called logging, and they also have something called cookie logging. And these in combination made us, when we started doing research with this, we went back a couple of days later and had like cookies for people signing in on the dot domain. which was really bad. So AWS actually went back and like, okay, we're going to fix this. Because the fun thing is that SSL is not really like SOP, the same origin policy. SSL is like, oh, do you have a trailing dot? We don't care, it's the same thing. But the cloud providers did not care about that. There's probably a bunch of other cloud providers still vulnerable to exactly this. So when we blogged about it, we also went out and said like CloudFront as well as S3 are vulnerable to this specific thing. Another thing we saw during this time was that Trump got hacked. Trump was hacked earlier this year, and a guy posted like hacked by ProMaster, nothing is impossible, peace from Iraq on donaldjtrump.com. And when we saw this, we started like doing some small research, and I had another friend that was like taking a look at it, and we're like, this is probably a subdomain takeover because he was using a third party that was actually vulnerable to it. And a couple of days later, we see a tweet from Brian Krebs that says he got in touch with the Iraqi hacker, and he referenced the blog post that I did in 2014, which was like, yep, that's how it actually went down. So tools, there's a bunch of tools that has popped up. There was one tool that actually existed long before we did this called Subroot. Subroot is basically a Python script that tries to brute force using a bunch of resolvers, trying to brute force a bunch of subdomains. Nobody's actually developing Subroot any longer, so it's actually stopped developing. It's really fast and really good still. However, a friend of mine called Ahmed actually adapted that project. So he moved it over to something called Sublister. And Sublister is basically trying to both doing brute force, but also trying to use a bunch of external services that like certificate transparency, passive total, Google, and Netcraft, and try to collect all the subdomains to do stuff with them. A bunch of other projects have popped up. There's a C implementation for a high-performance DNS resolver, which is basically called mass DNS. And what it does is like super fast trying to resolve all the things you actually have. So if you give it a bunch of domains, it's able to actually resolve them really fast and give you back the result. And to get these really good lists, there's also a project from a friend of mine called Shubs. He actually did a permutation script. So basically, you give it a bunch of subdomains, and you give it a bunch of like staging, live, production, demo, whatever, a word list, and then we'll combine that. So we will make like www-staging or .staging or staging www or staging -www, and try like create all these mutation lists. And combine this with mass DNS, you have a really powerful tool to actually get all these domains. There's also a project from another guy called Anshuman, and Anshuman actually built a TKO subs, it's called. It's basically looking for subdomain takeovers, but instead of just finding them, it actually takes the domain over automatically, which is kind of a douchebag move. Like that's not really how you want to do it. Sometimes, if you're doing this continually on a company, you can see that they're vulnerable in a couple of hours, like they're moving a domain or something. And if you're having this running all the time, you'll just claim it in the middle of them trying to do stuff. So that's pretty messed up, but there's a competition in this trying to find all these domains and trying to prove that they're vulnerable. So this is like one adaptation of trying to be the fastest to actually show that they're being vulnerable. And what are they actually looking for? Like there's one concept of actually looking at how they actually resolve and looking for patterns into the records. So in this example, you would look for pointing to buckets at S3 or GitHub or looking at Heroku app. But that's really not the way to do it because you need to resolve them and you need to also see if they're not resolving, and you need to use those in combination to actually make sure what happens. So one of these things that happens is, and one of the things that the tools are missing out on, are dead DNS records. What is dead DNS records? It's basically something that really doesn't look like it's there. If you're like making a host request to it, it will say like NX domain, this doesn't really exist. And this doesn't really exist. But if you look at admin.trello.com, that will also say like this doesn't exist. But if you start digging deeper, you will see that admin.trello.com actually points to prod.trello.local. So that actually has a record. So the difference between we cannot resolve and it actually has a DNS records are totally different. And none of these tools are actually checking for if the actual record exists or not. NX domain is like, whatever, it doesn't exist. And that's a really bad thing, because there's examples of, here's a game.westernunion.com a couple of years ago. I found this, and it was pointing to the westernuniongame.com. And that one was up for grabs. And the cool thing with this vulnerability is that you could actually look at the expiry date of the domain and see that this was actually 9 years old. Nobody has seen this for 9 years, and nobody actually touched it. So that's also one indication. These guys have a public bug bounty. So that was an indication that all the tools out there are actually missing out a bunch of issues. A guy called Matthew Bryant, or also known as mandatory programmer and mandatory, I don't know, mandatory, a bunch of stuff, prefix mandatory. He actually posted last year a really interesting attack method. And what he was looking at was not looking at domains that doesn't exist, but domains where the name server says, don't ask me, I don't know. Or it says, no, I'm refusing to answer your DNS request. Those called surfail and refused. Those are the DNS errors that he was actually doing a research around. And he noticed that a bunch of cloud services having DNS services was actually allowing anybody to actually take these domains. He was focusing on Apex domains, meaning blah, blah, blah.com. So he took the .com list from VeriSign and looped them through and looked after all of the ones giving refused to the name service they had. And then he checked those name services or name servers and see what type of service that they were using. And he noticed that a bunch of them had AWS Route 53, which was one of the services that doesn't really care who's owning the zone file. And when I read this, I was like, okay, this does not sound good, because there's something called subdomain delegation, which means that a subdomain of your Apex can contain a different name server. So you can delegate a subdomain to a different name server. And when I talk with him, like, you know that there's subdomain delegation? And he's like, yeah, I haven't looked in it. There's probably people vulnerable to it. And when we did that, we're like, holy fucking Christ. Like, this is actually a big problem. Like, a bunch of people using Route 53, for example, every time they launch a new app, they actually create a zone file for that subdomain owning the records of that specific app. So they don't have a huge amount of things in their regular zone file. They have like children's zone files all over the place. And that meant that a subdomain that had a name server that says, no, we're refusing to answer your DNS call because we have a different name server than the parent and the Apex, you could basically go in and just take that one. And the status codes for this was basically like, the no error is the regular one, like that resolves, everything is okay. Then an NX domain is like, we don't exist. This doesn't exist. That one could still have a DNS record. That's one of the points I was showing with the Western Union. And then you need to actually ask the name server more. And what Brian showed was like, the refused is, we don't know, like, we don't like this domain. This was something that Route 53, DigitalOcean, and the Cloud DNS was actually like doing with these domains. And also the surfail, that one is not even responding. That means that the name server connected could also be a domain that has expired, for example. That happens a lot, or typos. And the tools find the no error. That's the focus. Everything is focused on the no error. And all other three is basically just ignored. If you look at these codes for subroot, for example, it basically has like, okay, no error, do your thing, look if it's a CNAME or A. If it's an NX domain, just whatever. And if it's something else, just whatever. Don't do anything. And the subdomain delegation that we actually tried when we saw what Matthew had done was basically an example of lab.example.com was giving you a surfail. When looking at the name servers of that subdomain, you can see that this is a subdomain delegation, basically. So example.com points to 4 specific AWS DNS records for Route 53, but the subdomain has its own 4. And looking at these 4, you could actually collect these 4, save them, connect the AWS command line interface, and say, I want a new zone for labsexample.com. And when you do that, you get your 4 own name servers. But if you combine that and start like looking for similar matches, as soon as you get a match and these ones are connected, you can actually just take the domain. Because if one of the name servers actually responds, that one will be the prioritized one. And what happened also, you can get some really funky stuff going on with Route 53. So if you get one of them, the other 3 will upgrade to its siblings, which is interesting. So you can basically eliminate the error and just take over the subdomain completely. So basically then you host the zone file of labs.example.com. Another thing, and like just to summarize, nobody's like looking for this. So please start doing that. Another example of another thing that Matthew talked about 2 years ago was orphaned EC2 IPs. And the EC2 IPs is basically, when you launch an EC2, you have the ability to connect an IP to it. You can reserve an IP, which basically means that if you restart the EC2, you will keep the same IP. But if you don't reserve an IP, it will just take a new one. And if you're pointing your DNS records to the old EC2 IP, and somebody just reboots that, it's basically just a reboot. You will get a new IP, and that IP just released into the void, and someone else can take it. So trying to like automate this, like how do you find orphaned IPs? I tend to like look at the titles, like I find all the subdomains and I look at the titles, trying to strip out the ones not connected to the company. I did that on one site, and one just popped up, and I was like, this is weird. This is a site building CAD interfaces for doing furnitures or doing like houses. And when I go to their dev.on.site.com, there's a web shop. This web shop looks really, really funky, right? This is actually a web shop for cannabis. And this is a startup in San Francisco, and they suddenly have a subdomain with a web shop selling weed. You should take a look at this site. It's freaking awesome. I've never seen a site like this. It's so weird. But basically, I told them, like, hey guys, so you have a web shop. You don't know that, but you have a web shop, and this web shop actually sells weed. It sells weed to like the California people, but it still sells weed. And this doesn't look promising to your investors. Like you should probably remove this. And what happened, like 5 minutes later, they're like, hey, here's $300, thanks. And they're like, a couple of hours later, realized what happened, and they're like, oh, okay, here's $250 more. Like, oh, this is so embarrassing. Like, that was the worst thing that could happen in terms of this orphaned IPs. So the flow is basically, the flow that needs to be modified in these applications is basically brooting all the things, use mass DNS, subroot, whatever, collect the no errors, and the no errors are the ones that actually doing something, giving something back, and look for patterns in those. Collect the serve fail and refused, and if you get those, try to trace the name servers and collect the name servers that actually gives this refused, because you can find a lot of like fun examples of this. Is basically AWS Route 53 gives you 4 name servers. Some people are typing them manually, and one of them are not really a proper domain. So basically you have one of them actually giving you errors. And that's the fun thing. You can actually find name servers of valid domains. 3 of them are totally fine. 1 of them is not. And what happens is that AWS Route 53 is doing like a round robin for the DNS. So you can get like a 25% hit due to one of the name servers being expired. And you take that one, and then you can play around with it, which is quite fun also, because you never really see it, because if one fails, it will just take another one. So you can have a failed name server in your DNS zone for how long there is, until someone takes it, and you start getting 25% loss, and somebody else gets that hit. Also, NX domains, you need to like collect. If it's a CNAME, you should actually take a look further, because a CNAME is basically a shortcut. It says like, use everything I have from this domain instead. And then you need to like move forward, and you need to like almost like recursive look for patterns in those things. And you can find stuff like subdomain gives a NX domain pointing to a CNAME, and that CNAME has like a vulnerable name server. And you can like do fun stuff with that. Also doing resolve, check the no error for patterns, looking for these vulnerable services. Check the NS for patterns, same thing with the serve fail. And the NX domain, you need to traverse up to Apex, and also check if the Apex is vulnerable, because if that one is vulnerable, you might have found a domain that doesn't really exist at all, and you can register it. And also like try to improve this. Collect all the subdomain names that you have, the suffixes, sort them by popularity, and like I tend to sort www because you know that one exists, and you sort them below the ones having the popularity like above 2. And then you know that as soon as you get to W, you probably like looked for the most common ones at least. And then analyze unknowns, looking for the titles of all sites, filter out the common titles, like if the title is the same as the domain, and also generate screenshots of the chunk of data that you have so you can actually see if there's some patterns. And do this every day, all the time, and push your notification changes. So one thing I do is basically, I got this in January on the morning. I was leaving my daughter for daycare, and I saw my email like, oh, bounces.uber.com is pointing to S3. That's super weird. And I looked at it, and yeah, it was vulnerable. So I took the domain. I went to S3 and like, this is my domain. I took it over. But then I started looking at the DNS records, and I was like, okay, so this points to sparkpostmail.com, which is like a server provider for like tracking bounces. And that one was pointing to like a static IP. But it turns out that that static IP was released, and SparkPostMail stopped, like they stopped using that domain, and that one was taken over by S3. So S3 just, because they like need their own IPs and just take them when they're orphans and just host them, suddenly Uber was one, and I can just place my site, like my website on there and like trigger XSS and stuff. And Uber was like, okay, the best kind of bug fix is we should just delete everything because we don't use this anymore. And they were like, hey, here's $1,000. So there's a bunch of guys doing this. There's like a competition, and I really want to like challenge these guys and get other people to do this, because we're like 5 people that actually are doing this systematically. These 3 are my biggest competition. It's Matthias Karlsson, Anne Swinen, and Luke Young, which is like 3 guys that are doing exactly what I'm doing, and they realize the same things as I've done. So this is really my competition. However, I actually graphed a chart on my bug bounty rewards from back in 2014. And looking at the trend on takeovers, this is just takeovers. You can see that it doesn't really matter having that competition because there's so many doing it wrong. You can basically see, do you see anything? Okay, so you see the dots. That's the trend. So the trend goes up to there the last month. So shit is happening right now. Everybody's vuln to this. Nobody's doing anything particular to actually solve this. We try to automate it for Detectify and our customers, but it's still like so much vuln for it. Here's a guy with a horse. I hope I'm going to manage this, another mutation of this problem is called email snooping. A Nepalesian group of white hats actually went out a couple of months ago, like October last year, and they said that they were able to actually read Uber's emails. And they also thanked us for bringing this to light, because that was one of the reasons they were actually looking for stuff. And what they actually found was that there's basically 3 email services that people use. If you're not using one of these 3, you're using one of these 3, basically. You don't know it. That's the difference. So those 2 in being vulnerable is Mailgun and SendGrid. And AWS SES is not really vulnerable to this specific thing. But what these Nepalesian guys actually saw was that they didn't use any verification at all. And you can just go in. If somebody pointed something to Mailgun and was using that, they also exposed an MX record, and that meant that they could actually receive emails to that host. But if you only use them for sending out emails, you still had to have an MX record from them, which basically meant that and they also have this thing where they're like really good at sending emails, but they also want to receive emails and make it easy for you to receive them and have webhooks when you get an email and stuff. So that service had no verification, and they saw that they could just go in, say that this domain is mine, and get all the emails for that specific one. And when I saw this, I was like, okay, so this is super interesting. And yeah, MX records is inbound mail only. Doesn't really apply to outgoing. And when I saw this, I was like, this is not fixed at all. And I took a look at it, and I saw these services called inbound mail and also being able to add new domains to your Mailgun account. And when I tested, it said, the domain is already taken. And the other one said, no, you need to validate the domain. And when I looked at the request was to API version 3, claim domain. Guess what I did? Version 2, not patched. Could just claim the domain again. And I was like, okay, so this is bad. The other one, and they actually fixed that, of course. They were like, okay, now we're going to fix all our API versions. The other one was like, okay, so the domain is now taken. Nobody else can use it. But if you want tracking, please add a CNAME to email.yoursite.com and point it to us. Please do that, because if you point it to us, we can actually track emails using a subdomain of your own, and it looks really fun and awesome. The problem is with CNAME inherits everything. CNAME inherits MX records. So pointing a subdomain to an MX record means that you get the to another domain means that you're getting the MX records on that CNAME. And combine that with the whitelisted aliases, basically meaning there's a bunch of aliases, 5 of them being in the specification of how SSL verification works. So if you own one of these aliases on an email, you're able to actually issue a certificate by an okay way of doing it. They allow that to be done. So combining this with this one, having a CNAME inheriting MX from Mailgun, you could just add the example.com instead, the email.example.com, the subdomain, and suddenly you have a postmaster, and you can get the postmaster emails, and you can issue certificates on that. And when we saw this and we started talking with people, we were like, okay, we understand everything. This is bad. Another guy, he was like, yeah, when I read the blog post about this, I was like, this guy is gonna come to us and do something. And I also went to the Nepalese team and like, yeah, but you forgot about this stuff. And they're like, oh, fuck, I wish I found that. Yeah, and basically, some final notes about this is basically, there's a guy called Inti from Belgium. He actually did a really fun thing earlier this year, and he was able to actually found a tweet by Donald Trump that referenced a website that expired. So what he did was actually find this expired domain and put a YouTube video on there that was just a parody of how Trump like dances in Russia and loves Russia. And so that tweet is still there, showing that Trump like has been there in Russia and stuff. Also, a really fun thing was that when it was 2 years ago or something, will.i.am, the like R&B artist, actually went out and like, someone hacked my Twitter account. And somebody posted like hack.i.am because he owns i.am. And going into that website, you're like, okay, this is actually an S3 bucket and somebody can just take it. And it was like this for so long. They have like wildcard.i.am. And you can place whatever you want on that domain. And it has been like that for so many years, but suddenly something happens. And he just moved it to CloudFront, being vulnerable in the exact same way. So now you can claim whatever you want for i.am. Sorry, will.i.am, but he knows about it, but he doesn't care. So it's like a charity version of a website hosting. So basically, know your DNS zone files. Everything, you need to make sure that everything is connected to everything, and you need to monitor this. Automation is the only way to actually solve this problem. You can get some of the services actually starting doing domain validation. Some of them will never do that, for sure. And will.i.am loves this thing with subdomain takeovers. Thank you very much. All right. Cool. Yeah, sure. Anybody have any questions? Here's one.
Could Amazon simply resolve the problem by saying you can lock your domain? So the first thing you put on Amazon, you say asterisk.in, and no one else can block that anymore until I take it out.
Yes. So that's what Google is doing. Google has probably the best, they're probably the only one patching this today. And what they're doing is that they have one place of verifying your domain, which is Google Webmaster. So you validate their domain and then they connect everything to that. But it turns out that they've been vulnerable 2 times the last year, one being the Google DNS. Google DNS, they didn't really care about the domains you were adding. And that was what Matthew Bryant showed. And I also contacted them about subdomain delegation because they did properly with the Apex, but the subdomain they did not. So yes, that could be a solution to it. They however are well aware about this, and they're trying to like figure something out. They haven't really doing it, and they probably need something that on one level verify every domain that you ever own on your account by like some form of TXT records or something. So yes, but there's still one service out of like, now it's probably like 50 or 60 of them being vulnerable, and they knew about this since 2014, and they're like, yeah, we're aware. It's not that common, but it is. It is actually common. Someone else? Yeah. So yeah, Shubs has open sourced both alt DNS and he has another thing called Asset Note, which is basically Matthias also they have an open source project which is basically you can connect your widgets, one of them widgets being like collect all the subdomains, and Asset Note can regularly run tests on all these domains, and yeah, you probably know it. Yeah. Cool. Anything else? You can come talk to me later, no problem. I have stickers also. Cheers, thank you.